All right, welcome back. Good morning, everyone. I hope you guys slept well last night and are up early. I see only a few of you are here, which isn't too surprising how early it is. But we're going to, so we finished our discussion on database analysis yesterday, which was very good, I feel like, because again, what I want to get to kind of more of a practical aspect of database design is what we're going to introduce today is called ER modeling, entity relationship modeling. This is, I love modeling. I love models, producing them and understanding how they can be used. It is part of my focus of my research, and so therefore, of course, I would hope that I would like it, and it would be important. But first things first, So I think I forgot to do a quote yesterday, but this is a quote about modeling, and so quote of the day from James Bauer: "The best test of a model is how well can the modeler, the one creating the model, answer the questions, what do you know now that you did not know before, and how can you find out if it is true?" So one of the aspects of modeling in general is the idea of being able to express something, be able to express something of the real world in a way that's better understood, um, uh, especially to people who may not understand the finer details of what it is that we are expressing. And that's maybe that's hard to kind of, maybe I said that in a weird way, but basically a model represents something in reality. So when we model, when we create a model of, for medical purposes, we create a model of a human organ like the heart or the stomach or the brain. What we're doing is we're trying to create something that looks like or acts like something that really exists. And why do we do this? Well, for one reason, we might want to do it so that we can test out, how changes to that organ or that thing might affect the real world counterpart without having to actually do it. So for example, during this whole pandemic, all right, there's been a lot of modeling of human bodies, modeling of human organs and systems to help us understand how different things like vaccines might affect the human body without having to actually go and inject them initially, right? Because if we went out there and tried to inject or maybe do a surgery for other types of diseases and disorders on every human subject that might have it, one, we could cause a lot of damage to people's bodies without intending to, right? But by modeling it first, we can have an idea, okay, this is going to have this effect, this might have this other effect, and so we can test it out without having to actually test on human subjects first, which is good. Another thing that we can do with modeling is help us to be able to see things that we can't see with the naked eye very easily. So when we model a human organ or a human brain, we can see it in the computer, or we can see it in a drawing. It doesn't have to be a computer, it could be a drawing, could be a physical model, right? And we can see it without having to actually, take one of those organs out of somebody to be able to see it. Okay, so there's all kinds of uses for models. What we're going to talk about today, as far as the ER model is concerned, is helping us to be able to understand how a database, how the different components of a database system interact with each other without having to always necessarily have the database in hand. In fact, we can have the ER model be created in a couple of different ways, but primarily what I'm going to say is what we can do is we can either have an ER model that represents an existing database. So we may analyze a database and produce an ER model from that database so that programmers, so that users, so that customers can better understand how the database is designed and how the database is created. The other thing we can do is we can create an ER model based on a system that doesn't even have a database. We can create an ER model and then use that ER model to be able to create a database from it. Okay. If you think back to your 101, 102 days where we talked about UML, right? So UML shows up here. ER modeling is kind of similar to UML. It's based on UML, like a UML class diagram, right? And the thing about what I was going to say was, if you think back to your 101, 102 days, that the UML model, you could both create a UML model from an existing system, from an existing set of classes in Java, or you could create the UML model first to help yourself better understand what the system, what the code should look like, and then create the Java code from the UML class diagram, right? And so in the same way, ER modeling works the same way. We can use it to help ourselves, to help us and our customers and other users better understand the database that exists. We can also use it to create a database that does not exist from a high-level understanding of it. Okay. All right. So let's take a look at what an example ER diagram might look like. All right. So I know some of you, like, just if we were sitting in class, you would have just gotten this big wide-eyed, like, oh wow, what is that? Okay. Don't freak out. All right. At the end of this set of slides, you should be able to tell me what all the little lines and the blocks and all that means. Okay. But this is an example of an ER diagram. This is actually a very small example compared to real world systems. I can tell you that I've worked on systems that would have had something like 4 or 5 times this this amount of blocks in it, because each of these blocks, each of these boxes, just like in a UML diagram, each box in a class diagram would represent a class. Each of these boxes has the potential to represent a table. Okay, and in fact, there are some. Let me see if there's any. Are there any many-to-many relationships? Yes, there is. Okay, and in fact, some of these relationships represent tables, and in fact, some of these relationships, like for example, this one here, you'll see when we get there that actually this client preference, there would only be one table here, that the preference would be part of the client table, and we'll see how that works out when we get there. But remember, one of the things I keep saying is one of the hallmarks of engineering, one of the we would say that in American English, we would say the bread and butter. It's the kind of the foundation of being an engineer, is being able to look at something large like this and be able to break it up into its pieces and be able to understand those pieces and analyze those pieces. And so by the end of this set of slides, you will be able to tell me, okay, what is this dotted line? Why this solid line? What does that mean? What is this dotted line? Why is there this extra box over here? And what about this one over here? What does that mean? You'll be able to tell me, and tell yourself, more importantly, all these meanings of these different relationships and what these boxes are. Okay, so let's talk about some overall, like, what are some of the concepts that are important in an ER model? Some main parts that we'll talk about are entities, relationships, and attributes. Okay, so let's just overarching, these are the main concepts that you need to be able to understand, and we'll talk about them in more detail. over the course of this lecture and the next couple of lectures. All right, so entities, relationships, and attributes. Oh, one other thing that I do want to go ahead and mention early on. I want to mention early on here is because this requires a lot of drawing, I want to be able to draw these things. I would, if we were in a classroom environment, I would be sitting there on the whiteboard half the time. But unfortunately, we are not. We are on this Microsoft Teams meeting, which is fine. And I have the Microsoft Whiteboard application, but I have found that it is clunky. It is hard to use with the mouse and stuff like that. So what I'm going to try to do is I'm going to try to use, not today because I don't have it here with me. My one of my children is using it for one of their classes. But I'm going to try to do this using a tablet in the future with the whiteboard. And I'm going to see if that works out. If it doesn't, unfortunately it doesn't, but I'm going to do an experiment for next week. One thing what that means is early on, I want to tell you, so go ahead and let anyone know who's not here that next Monday we will not have a live lecture. I'm going to try to record something using the tablet and post that and see if that works. So I'm going to use that as an experiment. So we won't have a live lecture. I'll probably record it sometime later this week. You're welcome to join if you want and see all the clunkiness and craziness that may happen. The other thing is on Monday we'll have a quiz. Okay, so I'm going to have a quiz at, I have to do it at 8:30 because, sorry, no, that's on Tuesday. It'll be on Monday. The quiz will be on Monday. Yeah. I'll announce that. I hope to remember to announce that in the Microsoft Teams channel as well. But if I don't, if I forget, let everybody know there will be a quiz Monday afternoon. Okay. Anyway, back to the lecture. Sorry for that detour. All right, so we have an entity. So an entity will have a type, right? And an entity occurrence. And if you think about this as kind of like a class and an object in a sense. But the way that we draw entities in ER diagrams is a block, just like a class in a class diagram. Okay, but some examples of entity types might be something like this, where you have these things that have a physical representation in the real world. So like we'll have a staff entity. That the rows that exist in the staff entity represent something in the real world. They represent a person, right? They represent a person who works for our company. A customer, same thing, represents a person. We might have a property table, or let's say entity. Let me try to use consistently the word entity in this since we're talking about ER modeling. We might have a property entity, and the rows that will exist in that entity, the records that will exist in that entity, will represent a physical property, something that really exists. It could be an apartment, it could be a house, it could be, I'm not sure what else there might be. It's going to represent something real. Then there's this idea of something called a conceptual existence, where there may not be something physical, there may not be a person, but it's more of an idea of something that happens. So you might have a viewing entity, and what that represents is when a customer or some other type of user or something views a property, right? We need to have a record of that. Now, is there anything physical from now? There might be. They might. I can't think of anything off the top of my head of some physical representation of a person seeing a property, of looking at a property. Because when we talk about viewing, it doesn't have to be that they went out there physically to the property. It could be They looked at it online. I don't know how many of you have ever used Sahib and Den. My wife has. I have. I mean, we have. And anytime that she looks at a property, anytime she looks at an apartment that we might be interested in renting, uh, there was probably some type of record of her having looked at that property. All right, and that's a conceptual thing. There's nothing physical that's left behind that represents that. Same thing with an inspection. If we think of an inspection as a staff person goes to a property to make sure that it's clean and it's repaired and there's no problems and there's no paint chipping off the walls and stuff like that, right? There's no physical record. There's nothing physical about that. That was a person that went there and did that work, right? And so they did physically go to the property, but there's nothing really physical about them that sticks around, right? Physical, think of it as more kind of long lasting. A person is here, they work here, they are physical, they are there. A property is physical. It doesn't exist only as long as someone's living in it. It exists for good, right? So these are some entities we might create as part of our system. Stuff representing physical things, stuff representing conceptual things that happen, but we want to keep a record of those things. Okay. So here, just on the very basic level, right, just like a class diagram, we'll draw a box. And inside of that box, we'll put the name of the entity. So a box, staff, a box, branch. Okay, we'll get into, you're probably, some of you may be thinking to yourself, but wait a second, Hoja, we had other things below. We had what was it, variables or attributes, you called them, and then we had another section below that and it was called operations or methods. What's going on? Why don't we have those things? We'll get there. But if you think back, if you can think back that far, I know it's a long time ago, but when we very first introduced UML, we also introduced it the same way. We said the very basic UML class was just a box with the class name in it, right? And the reason why we have this notation is because for some of our entities that will become tables, for some of our entities, the list of attributes could get very large, right? And it could get very confusing. So if we go back and look, let me scroll back to this big one here. So this might be, some of the attributes, right, that exist inside. So notice there is this other section of attributes. It could get quite large, and in a diagram where we have lots of relationships like this, lots of attributes could get quite large, right? Could get very confusing for a lot of things, all right? So if we minimize this and say, let's have a notation where we just have the box and the entity name, then if we have a large diagram with lots of relationships, we might use this for that. And we might have a secondary diagram that includes all the attributes in some of these entities for smaller subsets of our large diagram. Okay. So anyway, at the very basic level, this is how we do it. That's how we draw an entity. Okay. Now, entities can be related to each other. Now, we'll have a relationship, right, that exists between entities. Lots of different types of relationships exist. I want to make sure that you understand the term relation and the term relationship are not the same. Okay. All right. The term relation is another word that we might use interchangeably with entity or table. Okay. The word relationship is telling us how two entities are related to each other. Okay, just like in UML. Yes, a relation we use that term interchangeably with table. Yeah, you're going to hear me use the word entity, relation, table interchangeably quite frequently. I'll try not to use entity that way too much, only because entities and tables are not always one-to-one. Relations are. Relations are one-to-one with table. But entities, sometimes one entity can become multiple tables. Sometimes two entities can become one table. And we'll see how that works out later in this. I don't think it's in this set of slides. I think it's in the next set of slides, but it may be here. Sometimes I get this set and the next set kind of mixed up because it all kind of flows together in my head sometimes. I'm sure many of you can relate. Okay, so, but a relationship is always going to be how two things relate to each other. In the case of what we're talking about today, a relationship is how two entities relate to each other. Okay. Not all entities are related to each other. There's not always a relationship. Just because two entities exist doesn't always mean there's a relationship between the two. All right. But if a relationship exists, it must be between two or more entities. All right. Let's look at an example. All right. We can say there is has a relationship. So what does this remind you of? This should remind you of an aggregation or a what's the other word? It starts with a C in UML. Composition. This should remind you of an aggregation or a composition relationship in UML, and it basically functions the same way. We're saying that a branch has staff, right? And the way we word this can go either way. It could be it doesn't have to always be the word has, but the idea is there. Is that the branch has staff members, right? And a staff, you could also say a staff works at a branch. Okay. So the way but whatever way that we are stating the relationship should work, the arrow should flow in the way that we would say it in English. Okay. How would you say this in Turkish? It would be a branch has staff. Branch bölüm işçileri var. Right? Bölümün işçileri var. I think that's how you'd say it, right? So yeah, so the has a relationship should remind you of the has a relationship, aggregation, composition type relationships in UML. Okay. And the way we would draw them in UML, same way we would draw it here in our ER diagram. All right. So here we say a branch has staff. Now, it does not matter. It does not matter whether the staff is on the left or the branch is on the left, right? But however we read this, the arrow should point from whatever is the owner and whatever is the owned in this type of relationship. So if we put the branch on this side and the staff on this side, we could still use the word has, but we could put the arrow there. Okay. So we can have a degree, different degrees of a relationship. So 2 is the most common, a binary type relationship. So this is an example of a binary relationship. Two entities are involved. Okay, but we can have relationships where more are involved, where 3 or 4 are involved in a particular relationship. So the most complex, let me just say, in practice, 2 is most common. 3 shows up some. 4 is, I would say, quite rare. It's very rare to have a 4 or more entity relationship, mostly because the way that it ends up being represented through foreign keys, and we'll get into that, through the way that it becomes represented using foreign keys, becomes quite complex with each new entity that you add to the relationship. So 2 is very common. 3 and 4 are more rare, but that's not to say that it doesn't exist and it's not useful. So you might say this would be an example of a 4 entity relationship. Okay, and the way we would read this is a solicitor arranges a bid on behalf of a buyer supported by a financial institution. So that's a lot of words and a lot of meaning, right? But basically the idea is that when a buyer wants to buy a property, so remember this all of our examples are going to be based on this dream home thing where you have people who own properties and people who rent properties and stuff like that. So the idea is that a buyer, if they want to buy a property, cannot just go out and buy it, okay, in our system. And I honestly don't know how buying property, I've never bought property in Turkey, so I don't know anything about how it works, but I do know how it works in America, and I'm assuming based on what I'm seeing here, similarly to the UK. This text comes from a British curriculum. All right. So, but the idea is that if I wanted to buy a house or buy a property, I couldn't just go out to the seller and buy it. Right? I'd have to go get approval for a loan from a bank. I'd have to submit a bid. I'd have to go tell the seller this is what I want, because let's say that they wanted to charge $100,000 for a property. Let's say that was the selling price that they listed. We never, in America, we're told you never just pay the price for a house, right? You always come in at some lower price and let them negotiate. So I bid $90,000, right? And then the solicitor in this case would be like the MLOC, or what we would call a real estate agent. Okay, so we want to know for each bid that gets sent to the seller of the house, we want to know, okay, who's the buyer, who was the MLOC, who was the real estate agent, and what bank are they using. So we want to keep all that information together because that represents that bid. The bid is kind of the central point, right? That is the unit thing, the one thing. So for every bid, there will be one buyer, one solicitor or MLOC, one bank, right? A buyer may submit multiple bids. A buyer could have multiple bids. A solicitor could arrange multiple bids, right? A financial institution may support multiple bids, but for every bid on a particular property, there will be one buyer, right? One solicitor, one financial institution. All right. So for that bid, we want to know all that information. We want to keep it together, right? That's why this relationship would exist. All right. I want to skip over this one for a second because it's the simplest one, so I'm going to come back to it. But here, another example of a three, in this case, 3 entity relationship. We have a staff is going to register a client at a branch, And again, we want to keep that information together. If a client, a property owner, or a customer exists at a branch, we want to know who registered them. Right? So the central, maybe the central relationship that, sorry, the central thing here could be client, right? It could be that the client is registered at a one branch. A client is registered using one staff, was the one who registered them at that branch. That could be how it is, but the branch could have multiple clients. The staff could register multiple clients, right? But it may not even be the client alone, because the client may be registered at multiple branches. Maybe they're registered at a branch in, I'll use Turkish cities. They may be registered at a branch in Antalya, and they may also be registered at a branch in Denizli, right? And so the client branch combination may be our single unit thing that we're keeping track of. And we want to know for each branch, who was the staff person that registered them there. Okay. And there may be some rules we can put in place on here, like a staff must work at the branch that they register a client for, right? And that could cause some issues later, but it may cause, it's just not a restriction we may put in place. Right? And then finally, back to the single here, single line binary relationship between two entities. Simply a owner owns a property, right? Can a property have multiple owners? No. Maybe not in our system. Maybe we allow it, maybe we don't. We'll see here in a minute. The way that they've designed this system is no, a property must have a single owner. An owner could own multiple properties though. Okay, that's the way that we're going to design this system. All right. There's also the concept of a recursive relationship. This did exist in UML as well. We talked about this in UML for 101, right? Where a recursive relationship is where the same entity participates more than once. So an example of a recursive relationship might be the supervises relationship, where a staff is supervised by another staff, right? Think about it like this. Here at this university, I'm a teacher, Melih Hoca is a teacher, and he supervises me, right? So we are both employees of the university. We're both staff. We're both employees of the university. And he supervises me, and he supervises others as well. Right? So this could be a recursive relationship where we don't want to create a whole other entity for people who are particularly supervised, especially because, let's say, Melih Hoca also has a supervisor, right? He has the faculty head, the decan, in English that's the dean, right? So he has a supervisor. So we don't want to have like, okay, let's have a table for teachers that are just teachers. Let's have another table for teachers who are also department heads. Let's have another table for the deans. Let's have another table for the rector. Let's have another table for, no, see, we don't want all that. What we would like to have is one table and have this recursive relationship represent that idea that somebody supervises someone else. Okay? So we have a recursive relationship. We can also define. Okay. We can also have two entities with multiple relationships between the two. Okay. So here, branch has staff, and a member of the staff entity manages branch. The branch has staff members. So one branch can have many staff members, and one of those staff members manages a branch. And the way we would make this happen, the way we would define these relationships will be different, right? These won't be the same relationship. But again, this is so that we don't have to have some separate table for managers. What we don't, so if we think about it in the university system, we could look at it saying like this, that the department has teachers. The department has teachers. 1 second, baby. I can't. I'll be right there in a minute. Okay, baby. Okay, a department. Please, I need to teach my class. Okay, a department has teachers. One of them is the department head for the department. Okay. And again, we don't want to have a separate table that would exist for the department head or the managers. We want to keep them together in the same table, in the same entity. Sorry. Trying to make sure I use entity. Okay. All right. You know what? Let me take a look. Let's take a break early because we're about to get into a section that's going to take longer than the 10 minutes we would have until our first break. So what I'm going to do is let's break here. I know it's a bit early, but we can come back a bit early as well. And so what we'll do is we will come back about 9:20, 9:22, 9:25. Okay, we'll come back at 9:25 and continue on with attributes. Okay, let me check to see if there's any questions. Nope. Okay. All right, so we'll come back at 9:25 and we'll continue our discussion with attributes and we'll move on from there. All right, see you in 10 minutes.